But yeah, hello. Thanks for coming, everybody. It's a bit weird because I've never done a hybrid thing before, so I've presented from a corridor in my house to people at an online conference, and I've presented at real-life conferences like this, but I've never done hybrid, so I don't know how many people. I'm assuming in my head that there's the same number of people who are kind of watching online, so hello to people online. And I've also been told I'd love to have questions, because this talk kind of comes from a bunch of rants that I've engaged in over the years. So I thought if I turn it into a talk, I can just send people a URL and then they can watch it. But it usually then creates loads of questions. So if you do have questions, please come and ask them on the Rocket app. I've been reminded to ask. And if you don't ask them on the Rocket app, I have been told to repeat your question out loud. So hopefully I'll remember to do that. And then we can have a quick discussion about it. I'm also here for the rest of today and tomorrow. So if you want to find me and disagree with me or agree with me or ask me more questions, please do. Because I love talking about domain-driven design. So there's people who I've worked with for quite a long time sitting in the audience, and they know that I continually go on about domain-driven design. So this is the talk. Domain-driven design. Domain-driven design has been around for ages. I'm going to talk about how long it's been around. I'm going to talk about kind of prehistory of domain-driven design, super prehistory. But the reason I think this talk was accepted, because I may have submitted it to Devox more than once, was that domain-driven design is becoming is a buzzword again in the software development and software delivery industry. So I've got a training course on O'Reilly where I teach in 3 hours, you get to write code and you get to do the core bits of DDD. The reason they paid me to write that course is because the searches for DDD and domain-driven design on the O'Reilly website are going up. So there's a lot of people wanting to hear about DDD. So DDD is awesome. DDD is also problematic because it's been around for a long time. There's tons of stuff which is called DDD. There's tons of people who say they're doing DDD. There is controversies and debate and various communities and all of this kind of stuff around about DDD. So as a consequence, DDD has kind of ended up in the hands of architects who are typically people who don't have to write code, so therefore they've got lots of spare time so they can read thick books and have big thoughts about software, whereas developers are too busy trying to write code and get stuff done. DDD is for developers, and the point of this talk is to hopefully convince you that that's the case, and then you can go off and read the book or join some of the communities or whatever. Do some DDD. That's the point. So it's really big. It's been captured by architects, but like I say, it's also been around for a long time. So what I'm going to do is take a kind of historical view. So you've probably watched at least one Netflix documentary these days where there's like a timeline and you zoom back and forth on the timeline. We're going to zoom back and forth on a timeline to kind of tell the story of DDD and how it came about or how it grew in the software delivery industry, to then kind of give you an idea of the landscape of DDD, so therefore you can disambiguate what people are talking about. That's the goal. So we won't go into depth of any piece, but then I'll kind of, if people have got questions, I can point you towards tons of stuff, because the community around DDD is awesome, and there's loads of stuff out there. But what I want to do is give you a broad idea so you know where you can go and what you might do to start. That's the plan. So to do that, we're going to go back in time. So there's a timeline. I need to remember that's the future, this is the past. So we're going to go really far back to the past. So we're going to go back to 1919, before domain-driven design. So in 1919, a school was founded, and it was an art and crafts and architecture school. It's called the Bauhaus. It was founded, like I say, in 1919 I think it was in Weimar, in Germany. In 1925, it moved to Dessau, I'm not sure how you pronounce it, in Germany. And then in the 1930s, it moved to Berlin. Obviously, that was not the best place to be if you wanted to be a kind of collective, free-thinking, kind of creative type place, but it was. Then it disappeared. So we're going to talk a little bit about the history. The Bauhaus was set up by this man, Walter Gropius. Walter Gropius had fought in World War I and had obviously had a not very nice time. And so when he came out of World War I, he had this problem which was just kind of sitting with him, and he couldn't figure out what it was. And the problem was how to live in the modern world, because he'd seen kind of an older version of the world turn into World War I with all of the bad parts of technology and all of the bad parts of, all of the different power structures and everything. So what he wanted to do was solve the problem of living in the modern world. And he did that by taking the commission by this local authority, basically, in this place called Weimar, to build this school. But he kind of got free rein, so he kind of did what he wanted to, right? So he built this school, but it wasn't just a school, it was a collective. It did loads of stuff. They made physical things. The range of the physical things, we'll see some pictures of them in a minute, but the range of the things that they built was incredibly diverse. We'll see some of those in a minute. The range of the thought and the approaches and the skill set of the people who taught at the Bauhaus was also equally diverse. So it wasn't just one set of people with one way of doing things. There was many different ways of doing things. And so what he needed to do to bring all that stuff together to make something which was actually useful, because fundamentally, and this is important, and this is all going to come back in DDD, the Bauhaus was there to teach people how to make things. It wasn't a philosophical exercise. The point was to solve the problem of living in the world. And so his solution to the problem was this, that form follows function. What does form follows function mean? It wasn't created by Walter Gropius. This is an age-old kind of phrase that you hear. But fundamentally, it means that the shape of the thing, the design of the thing, how the thing works, follows directly on from the problem or the needs of the user that you're building that thing for. So you don't have all these fancy extra bits flapping and all over the kind of stuff. It's like if you're building a house, you need to build a house that helps people live. If you're going to build furniture, you need to build furniture which is comfortable to sit in and does all these things. That was the philosophy. Form follows function. So remember that, because it's going to come back. Although it'll say it on the screen in big letters, so you don't need to remember it. So let's quickly look at some of the stuff, because like I said, they built a ton of stuff. It wasn't theoretical. They did tons of stuff. This is a teapot that they designed, which apparently is an awesome teapot. I don't like the look of it, but anyway, it's a teapot. You might recognize this chair. This chair was designed at the Bauhaus. So they've taken away, you can see here, one of the fundamental principles, lots of the things that you think are part of a chair aren't there because you don't need them. So form follows function. Which bits do we need? Which bits do we not need, but we just put on chairs because that's how chairs are designed? Why are we putting them on the chair? We don't need them. We've got modern technology like metal and things. They didn't just restrict themselves to these things. The thing has died. They had parties because they were a collective and they were kind of like just living their best lives. Key things you can see here is super creative. There is an equal number of women and men. In 1920s Germany, in 1 year, there were more women students than there were men. So this bounce doesn't last all the way through, but you'll see it. So it's a different kind of place, right? Next up, they didn't just go and have fun and get drunk, probably. They designed things like whole ballets, including the ballet sets and the costumes for the ballet, all this kind of stuff, again, wide-ranging. They even produced works of art. This work of art will continue to become familiar. If you pay attention to that work of art, it might pop up again a few more times. Works of art. And most importantly, or not most importantly, but also fundamentally, all the way up to the scale of the buildings themselves. So the people who worked in and attended the Bauhaus built the second Bauhaus. So this is the Bauhaus in Dessau. They designed and built the buildings, the whole campus, the interiors, all of the parts of the Bauhaus. So that's the Bauhaus. We're now going to zoom forward, which doesn't work if this is working. No, it doesn't work. Zoom forward in time. So now we're talking about DDD. 2003, this book, the Blue Book, as it's called, was published. It, too, was trying to solve a problem. And it's there on the cover, but it amazes me how often you hear people talking about DDD, but they don't know what the subtitle of the book is. It is tackling complexity in the heart of software. Because software was in 2003, and I think is possibly even worse now, is too complicated. So the whole point of DDD was to tackle that complexity, right? And then you get a thick book. Again, like the Bauhaus, it ranged from the very small, the very hands-on, the very practical, all the way up to the large, the significant, etc., etc. It's super universally applicable, but there's also very specific hands-on, if you have this problem and do this thing, your life will get better advice. So it's philosophical and everything. But what is the philosophy that joins it all together? Well, the philosophy comes from this man, Eric Evans, who wrote the book. And Eric's philosophy is this: put the model to work. So this is all the way through the DDD book. And so what put the model to work means to be able to solve a problem in software, to tackle the complexity, and the complexity, he says, is the business complexity, the complexity of the problems our users have. That's what we should be solving, not how to do the re-election of a failed node after something's gone wrong in your Kafka cluster, right? Or how to figure out how to do distributed tracing in a microservices architecture. That's accidental complexity. The real complexity is how do I solve my business users' problems? He says put the model to work. Because in the old days, and still today, which is why DDD is still good, we understand the business problem. Lots of it, if we're developers, or maybe if we're product people or BAs or whatever, we spend lots of time and effort understanding these problems, and then we forget it and we write code. He says, take the understanding of the business problem, the model we have of this business world, and we put that down into the software. That's what it means. If that sounds like form follows function, and if that picture looks familiar, then you realize I'm not just talking about the Bauhaus for no reason. This philosophy, which came before the Bauhaus, goes all the way through the Bauhaus and all the way to right now in software today. It's form follows function. Take the understanding of the problem that we're trying to solve and put it in our software. So we saw some things that they built at the Bauhaus. We're now going to see some less exciting screenshots of bits from the book, because that's the DDD equivalent. The first two are super fundamental. If you're not aware or doing these first two, or if someone says they're doing DDD and you can't see the first two, they're not doing DDD. They might be doing good software, it's just not domain-driven design. So number one, ubiquitous language. So what problem does ubiquitous language solve? Lots of the problem in software, and I'm sure everybody here and online sees this all the time, is a breakdown in communication between the people who have the problem we're trying to solve and us who are solving the problem. So what do we do? If it's a communication problem, we speak the same language. That's what they mean by ubiquitous, which is not the best choice of word, because most people need to go and look at the dictionary to find out what it means, especially if English is not your first language. But it means everybody speaks the same language. So we speak it, we write it, we draw with it, and we code. And this is the big thing. We're putting the model to work. If the code doesn't contain that language, then it's not gone all the way to the code and we're not doing DDD. Important point number one. Number two, model-driven design. The pictures in the DDD book are super clever, and I only recently realized this recently how clever they are. That's an astrolabe. That is a physical model of the heavens put into a thing to figure out where the stars are. So it's not like a black box and you type in some numbers and some numbers come out. The physical design and shape of the astrolabe is based on the physical layout of the stars. So, model-driven design. Like I said, if we have shared language everywhere apart from in the code, then we've lost out. We've done all the hard work and we've just failed to put the language in the code. So what do? We tie the code directly to the model. So the code is the model. The idea, the solution to the problem is the code, and the code is the solution to the problem. And it's the same language, the same diagrams, everything. We're not drawing a picture of something and then having a little conversation with our developer friends and saying, actually, when we say that, we actually mean it's a blah, blah, blah. We're using the same language. And the benefit being, this is why you do DDD, when it sounds like one part of the implementation is drifting away from the problem space, you can see fractures in the language. Things are not the same. You're needing to translate. So if you're translating, then you're getting it wrong. So that's fundamental, but there's some extra stuff. Next up is modules, which if you think that's just packages, correct, that's just packages. This is to show you how broad and deep DDD goes. Packages aren't just a place to put your class files when you've got too many class files, and when you open, expand something in your IDE, you can't see and you have to scroll. Packages have domain meaning as well, because people, when they have their mental models, group things together in certain ways to understand that mental model, to prevent them getting cognitively overloaded. We have the same problem in code bases all the time. I've done it, so why don't we use things like packages, right? And the way you do it in a DDD way is you use the words from the domain to name your packages. So utils is not allowed, unless your client, if in my case, or someone in the business where you work calls the thing utils, then you can call it utils. But utils is just us not knowing the name to call it, basically. Next up, entities. I'll do these ones very quickly, but just to show you all of the things that are from core DDD. All of these are from the Blue Book. Sorry, yeah, good question, go for it. if that's a name, sorry, the question is, you've seen packages named modal. Is that a good name for model? So that's a good name for the thing saying, we'll get to that in a second. In there, you should have further packages to say, these are the parts of the model. So it's good to name that because there'll be other parts that aren't in the model, like your REST interfaces and your persistence tier and all that kind of stuff. Keep them separate. But what you want to say is it's not just a big blob of a model, there'll be pieces within it. So you can use that too. So entities, some of those pieces, for example, might need to represent the identity of a thing. So an entity is just the identity of a thing. So you forget about all of the other things. You forget about the data attributes. You forget about all of the other parts of a thing. For example, like booking a seat. If booking a seat is important, there'll be an entity for a seat that you can book, and it'll have an ID and it'll have a life cycle. And that allows you to put that into your domain, and then you can use it, manipulate, and model it. The physical location of the seat is probably separate, and that's another piece of your model. So entities just let you focus on the identity of something. Next up, aggregates. Aggregates is the one that terrifies everyone, but it doesn't need to. And again, the picture here is super powerful, and I think maybe Eric should have explained the pictures more. On this picture here, the aggregate is the bunch of grapes, right? So that might help. The problem you are solving when you use an aggregate is you need to keep a bunch of closely associated, the individual grapes, but separate individual grapes. You want to keep them consistent, right? You want to treat them. You don't want to like track individual grapes, but you do want to track the number of bunches of grapes or do things to bunches of grapes. That's what you're going to do, right? And typically in software, when we're creating them, saving them, retrieving them from looking them up, you don't want to look up. If you want a bunch of grapes, you don't want to look up every individual grape from the database. You want to say, give me the bunch and I'll get the bunch back. And they come back all together. So you use aggregates. So aggregate says, in the real world, we would treat this thing as a group. And we'll, at some conceptual level, they all go together. So we'll treat them as a unit. And we'll call that unit an aggregate. And because we're treating it like that, we'll then have the aggregate as the place where you have to, all manipulations of that group of things, you need to go to this one centralized point to retrieve them, to update them, et cetera, et cetera. So maybe you're thinking, this sounds a little bit familiar. These are microservices. Aggregates are microservices. You'll hear a load of stuff which is wrong, and I will die in a ditch over this. Bounded contexts are not microservices. Microservices are aggregates. However, if you have small bounded contexts, we'll get onto that in a second, then maybe they will map one-to-one, but an aggregate is the thing. If you go through the book, you read the blue book, and every time you see the word aggregate, you cross it out and write microservice, that's microservice. It's the whole book still reads. Now we get to bounded context. Bounded context, what's the problem? We've got more than one model. Right, so we're modeling, we're solving more than one problem, and I'm sure everyone, you have the model package in your code base, you end up with lots of different pieces, you've got more than one thing. What do I want to do? If I've got more than one model, I need to keep them separate, because a model should be a separate thing that solves a separate problem. So how do I do that? I draw a line around the outside of it. That's a bounded context. A bounded context is just the line around the outside of a model to say, this model is here, and it does these things. And then you'll have another model with another line around it, and it says, this model is here, and it does this thing. And you name your bounded contexts using the language of the domain that come from your business users. So you don't use any technical language. Ubiquitous language.
I'm not quite clear what the difference between that and a package is.
So it could be a similar thing. Package could be an implementation. So the question is, what's the difference between that and a package? It could be that package is a technical implementation. So it's like how you might actually do it. You could do it like that. And like I say, sometimes you end up, if you've got a one-to-one mapping between microservices and bounded contexts, then you might end up with, these kind of groupings. The thing is, and Eric talks about this a lot, he talks about it in the aggregates chapter, he talks about it in loads of different chapters, he's constantly trying to give you new words like ubiquitous, which maybe got him into trouble, because he doesn't want you to use technical terms to explain stuff, because he knows if we start thinking technical, we'll start thinking SQL queries, database tables, TCP/IP, Amazon Web Services, and we'll be sucked into it. And he's like, stay in the problem space, stay in the domain, then map it, and we'll see that in a second. Then you tie it to stuff. And now you've got a problem, because you've got thousands of bounded contexts, because when you grok bounded context, they're awesome, and then you go bounded context crazy, then you need a context map to tell you where on earth you are. So you've got loads of them, so you create a map, so you can see where they all are. And at this point, because bounded contexts map really nicely to teams, because if a bounded context is one model and it all belongs together and it all goes together, if a team owned that thing, that would be really cool, right? So if we've got multiple bounded contexts with multiple models, and they're mapped to different teams, then that's also a map of our team relationships. So just like at the Bauhaus, there is a point to this whole Bauhaus thing. There is a low level, there's the stuff like ubiquitous language, putting the model to work, entities, modules, like packages, right? The thing that looks like a folder we put in our IDE. From that level, which is teapots, all the way up to this, like whole layouts of whole school campuses, it's all in the Blue Book. That's one reason why people go, this is too complicated, because it's all there. But because Eric knew that it was hard, he drew a map at the back of the book. But I can't find this, because all these screenshots were taken from the O'Reilly, should be a bit careful not slagging off O'Reilly. I can't find these in the O'Reilly online version of this book. They're not at the start, they're not at the end. This map, and there's two of them, are the best way of figuring out where you are in DDD. And you can see the two bits I talked about, ubiquitous language and model-driven design, same thing here. They're the core, that's how you get to all the other bits. They're the only bits you need to be doing DDD. Everything else is like, oh, I've got a problem, so I need to add entities or modules or repositories, which we didn't talk about, or layered architecture. It's like you don't even need, right? If you need it, you bring it in, right? DDD is like a set of tools you can use to help yourself fix things. It's not all or nothing. But again, people think, oh, these architects, they keep talking about this whole massive thing. It just seems over the top. It's just these two plus a bunch of other stuff. So these maps are really, really good. Oh, I can't press the button. So we're going back to the Bauhaus. So I mentioned before the Bauhaus was a collection of people. This is a less gender representative version of the Bauhaus, but these are the masters. So again, to have a one lady master teaching at the Bauhaus in 1925 was better than lots of other places, but it's not as representative as the class. So I also said there was a vast array, because this whole philosophy and the way that Gropius had structured the Bauhaus brought together people who were very, very different. So we can see here some of the stuff. There's that picture again. That's Vasily Kandinsky. He taught in the foundations class, and he taught about form and about shape. Because he's like, if there's a bunch of, if there's two fundamental things, form and shape and color, we'll see that in a minute. That's Paul Klee. They taught that. They're like, if you get that, then you just assemble stuff on top of it. But if you don't fundamentally understand that, then you're in trouble. Missing the class photograph. Johannes Meyer, he took over from Walter Gropius. Committed communist, ironically, was the first person to actually make the Bauhaus make money. So you figure that out. And also absent from this class photograph, Mies van der Rohe, also an architect. He was the one who ran the Bauhaus in Germany, so he got the raw deal. But I couldn't not mention her. So Gunther Stonsel, Gunther sits in between the two, right? So she's not super theoretical, she's practical. She's taking these things, and this is what's important. And again, maybe there's some lesson in there that the person taking the foundational, fundamental skills is the person who's less talked about, because she's not as famous as the rest of them. But she's the one taking the theoretical stuff from Kandinsky and Klee and putting it in the hands of people. She is making tapestries, making fabric, making things which are useful to human beings at an individual level and putting it into practice. And in the middle, Gropius, form follows function. So you can already see things are starting to get a little bit complicated. So things start to get more complicated. And a good example of this is in how accommodation worked. That student accommodation, obviously not that many people lived in that one student apartment, but they were pretty small. This is pictures of the master's houses, separate individual houses, detached houses in beautiful wooded scenery. And I couldn't find an outside picture, but this is just the living room of the director's house, which is Walter Gropius's house. So he'd founded it in a very non-hierarchical way. He founded it, it's super interesting to read about. There was cults got set up accidentally in the middle of the Bauhaus and everything. It's really interesting because he tolerated very different perspectives and he wanted different people to come with different things. But unfortunately, as time moved on, he's like, well, we need to have a big house because the person who runs the show needs a bigger house. And then the students don't need such a big house because they don't have so many things and they don't have kids. But accidentally, things got more hierarchical. So that's one thing you'll start to see. Or maybe not accidentally, but not, it began to affect things. And so we can see, and we're now going to leap forward back again to DDD. You could argue that this is a bit messy and a bit complicated. And unless you deeply really understand it, maybe you don't know where to go and what to do. And that's exactly what happened. So in 2013, this book was published. So this is 10 years after the Blue Book, and it's now talking about implementing domain-driven design, because people had loved all the DDD stuff, right? But they're like, this is hard. Can someone please just tell us how to do this? So Vaughan Vernon went and wrote the book. There's tons of people that he spoke to. If you look at the credits, they're now like a who's who of the people who are now kind of famous in the DDD community. He basically took, and worked with, sorry, that's not, he didn't take. He collaborated with tons of people to figure out how we do this thing called DDD, because it seems really good. We should figure it out. That's Vaughan Vernon. However, to do that, he had to make certain compromises. He didn't compromise on the fact that the first 2 chapters are about ubiquitous language and putting the model to work. However, the thing that he did next was he flipped the order of the remaining chapters. So when we talked about packages, entities, aggregates, etc., all the way up to context map, he starts after context map and works the other way. So now you're like, if you're reading this book, you've got to read a lot before you get to the bit where it feels like a developer is going to benefit from it, because we're talking about architect-y, team organization-y stuff. Right? So I don't think it was intentional, but that's, people are like, this book is thick, man, and right? So that kind of stuff is there. Also, some names started appearing. So these names are not explicit in the DDD book, the blue one, but you do hear them now. Tactical and strategic DDD. So strategic DDD is the big architect-y, team interrelationship, bounded context-y type thing, right? Where strategic sounds important. Tactical sounds a little bit messy. Tactical is all of the other stuff. So that's kind of all of this kind of implicit value judgment and stuff, just like with the houses, is coming in. So let's talk about some of these, because you will recognize these coming up as well when you come across the DDD community. So what's this? This is the first piece of new technology which meets this problem. How do we represent, if we're looking at a big picture, how do we represent the difference between what we have right now with our IT estate, right? A bunch of applications, a bunch of microservices probably now, right? An old HR system, identity and access, all of this kind of stuff, right? That's where we are now. And then we want to get to this beautiful place called bounded context and lovely microservices with aggregates wrapped up in them and, clean, beautiful architecture. But what we have is not clean, right? The identity of a human being, if I change my address, I have to go to 3 systems and change it. That's just how software works, right? Because software grew over time. So what we do is we introduce a new word to talk about where we want to be, and that's called a business domain or a subdomain, which again was kind of implicit in the Blue Book, but wasn't really called out. Now it's called out in the Red Book. So that's where you want to be, and where you are is bounded context. So there's this kind of tension, because sometimes they're the same things. But on the picture on the right, they're the same thing. And that's why people get confused with them, right? But the big thing is knowing if you're in as is or to be. Next one. Again, domain events were really, there's a really small mention in one discussion chapter, because lots of the Blue Book is discussion about events, but they're not called out explicitly. There's a bit of debate as to whether it's an entity or a value object. Meanwhile, events, the folks in the 10 years since that are like, this is important. We can do tons of cool stuff with events, right? And all the things we've heard of, so things like event sourcing, event-driven architectures, all of this kind of stuff. It begins to come from here, because domain events can capture something exciting that happened, right? So something happened, how do we capture it? We just capture it, call it a domain event. Like, my bank balance was credited with some money. Have that in your software. Don't have balance increment plus plus, right? Have the fact that your balance went up, and it's called a deposit or it's called a credit or whatever. Use that language in your software. So they were like, this events thing is really cool. We can get carried away with it. So the question over here, this is another big piece in the book. In the middle is the domain model, which is what Eric talked about. But people, and I get this on my course all the time, people are like, are we going to get to the bit where I actually write a REST interface or save the data? We don't. Because Eric just cares about his beautiful, clean model. It's a bit like functional programming, right? It's like at some point it's got to get non-functional because you've got to like read I/O or something. But like functional people, Eric pretends it doesn't exist. Or he doesn't pretend it doesn't exist, but he spends less time talking about it. Implementing DDD comes along and goes, yeah, but we're professionals, so we've got to make money, right? Like Johannes Meyer, who actually, the communist who made money from building buildings for people, they do this. So this is hexagonal architecture, which doesn't come from DDD, but it's a way that people do. You have the domain in the middle, and then all of the I/O is round about it, and it wraps round. So your domain doesn't know about anything else, but all the things on the outside know about the stuff on the inside. So that's how you do it. Also called onion architecture. But the problem is, we've got all these pieces, and now software, DDD is being done more. The spirit of it is slightly going, and architects are taking over. I am included in this, right? I'm an architect. But, the kind of this messy, you pick and choose what you want, and you can, as long as you start in the 2 gray boxes, you can go wherever you want to go based on the problem that you have to solve, that disappears. Or begins to disappear. Lots of people still know it, but you see, you can detect it in the discourse and in the kind of communications that people have, because people didn't want it depends as an answer. They want to do this first, then do that, then do that. So going back to the Bauhaus. 1930s was obviously not a great place to run an art school, so it got closed down. But the people there still believed in all this stuff, right? So they all get scattered around the world. Gropius is asked to go to Harvard and set up something like the Bauhaus in Harvard, but because it's Harvard, they're all wearing suits and they're all men, and some of them have got bow ties on. So you could argue it wasn't as successful as the Bauhaus, which was completely bonkers. But that thing and that mindset and that kind of form follows function way of looking at things is still there in North America during and after World War II. Another group, including the person who set up and ran the foundation course, the one which took all of these pieces which were later dropped by Johannes Meyer when he focused more on architecture, so again, sounds a bit like DDD, they went to form this school called Black Mountain, again in North America. It was far more true to the spirit of DDD, but also taught lots of things and did things, and still said form follows function. And Mies van der Rohe, after trying to run a school in 1930s Berlin, just started going off and building buildings. He went off and built buildings internationally, lots in Chicago, came back to Germany after World War II, still form follows function. But all of these interpretations of this thing, all of these people who had been intimately related with setting up and running the Bauhaus, if you look at the stuff they did, it's all massively different, but it still comes back to the same thing. And that's the third bit we're going to talk about with DDD. So I've kind of talked a little bit about the fact that DDD started with the Blue Book. The Blue Book talks about DDD. But then the Red Book comes along. It also talks about DDD. The Red Book is DDD. And so, but bearing in mind the fact that there are differences, it's almost like these two schools that you've got, or multiple schools, and there's even more schools of DDD that came along afterwards. Knowing this kind of thing helps people. It helped me when I figured it out, and it's definitely helped people that I've spoken to since. Understanding that, that all of these pieces, at the core, they're not incompatible, but as they grew and as they changed and as people tried to do things with them, they look very different. Right? So that's, sometimes some of the confusion about understanding what on earth DDD is because people are trying to make everything look the same in their heads, because that's how you understand something. If it's complicated, it doesn't all look the same because people are taking these fundamental principles and they're doing different things with them. So let's look at some of those things. So this is now, which I should have thought about a bit more before it was a hybrid conference. Does anyone know what this is? This. Yep. So 2 people said, I need to give credit. 2 people said CQRS, yeah, because it says it on the screen, right? CQRS, this is the diagram from the Red Book. CQRS doesn't actually need anything to do with DDD to be implemented, but because lots of people who do CQRS, including some of the people who innovated it, talk about DDD as a nice, clean way to do it, it became super tightly coupled in people's heads with domain-driven design. So what is CQRS? CQRS is command query response segregation, separation. Gayathrie's nodding. Gayathree knows more about it than me. but it separates the query model from the command model. It's basically, there's like the data, there's the things that you ask the model to do, you save those separately, basically as a log of events if you're doing DDD style, and then you use that to update the query model, and then the query model is read-only. So it's two different things, and then you can optimize for writes and optimize for reads, and then sync them asynchronously behind the scenes. If it sounds complicated, correct. It is incredibly complicated. I don't even really understand it. I'll admit that. But if we link it back to DDD, you don't have to, but if you do it with domain language, stuff gets a lot clearer, and therefore you can focus on separating the technical implementation from the domain elements. You've definitely got multiple models. You've got more multiple models in CQRS than you get in any other style of doing DDD. The thing that took me forever to figure out, and Gayatri, who I worked with before, actually figured it out after me. Sorry, I didn't figure it out. She figured it out and told me. Aggregates, the name aggregate is in CQRS, and it looks very similar to aggregates in DDD. They are fundamentally different in certain ways, and that confused the hell out of me forever. So they still exist, still do similar things, but they don't work in the same way. But it's all got events all over it, right? So very eventy. Next one. Anybody know what this is? Nobody? Microservices? Yeah, microservices. So microservices, probably don't need to explain microservices. Microservices are like hardcore. So Eric Evans, he did a Q&A at a conference I was at last year, and he said, DDD comes back in waves. One of the waves that brought DDD back, that raised the level of searches being done in DDD, was microservices. Because microservices were turning into an absolute mess. And I think they maybe still turn into an absolute mess, even if you're doing DDD. But if you're not doing DDD, microservices will definitely kick you behind, because I've seen it. Because if you're doing microservices right, they're business-focused, just like DDD. They've got multiple models, because unless you're linking your databases behind the scenes, which means you're not doing microservices, then they need to be separate, right? Because that's why you need your aggregates, because these things are created and live and die together, right? The state is manipulated separately. Got aggregates. Cognitive load, if done correctly, I realize this is a controversial statement, if you do microservice correctly, then it lowers cognitive load, because everything becomes a black box apart from the microservices that you maintain, so you could be winning. If you're a highly coupled, not a loosely coupled monolith, if that's a good thing, the opposite of a loosely coupled monolith, then it's an absolute nightmare. You don't want to do that. But you also get team splits, because like I say, you've now got these individual things in these individual repos, so we're right all the way from the beginning of DDD, right, ubiquitous language focusing on the business problem, all the way to the far end, which is the piece where teams are separate and they've got separate bounded contexts and they work separately. That's in microservices too, right? Goes back to DDD. Anybody know what this one is? Some people will definitely know this, and other people will be like, what is going on? Event storming, exactly. So this is event storming. This is what Alberto Brandolini's brain looks like inside, I think. So Alberto Brandolini is the person who invented event storming. Event storming is a low fidelity, fuzzy, collaborative, business-focused, technical, avoiding the technology, mass collaboration, mass design workshop format. And it's, I think, these days, the closest to the spirit of the Blue Book DDD of any practice that has sprung from DDD. Mainly because Alberto loves DDD, and I think knows Eric Evans well enough to give him abuse sometimes, and Eric takes it. But what's it got? So, it's got events. So if you've ever done the event storming, well, it's obvious, it's in the name. But the events, you start with orange stickies, so he gives you tons of stacks of orange sticky notes, and he says, think about all of the business events that you know about in your domain, so in your business domain, right? I've got a massive piece of paper which I've stuck on the wall. Please write those events in the past tense, business language, nothing technical, stick them on the wall. And then the workshop grows from there, you stick them in order, so you've got a timeline, et cetera, but it's fundamentally event-driven. Business focus, because we're only allowed to talk about business events, we're not allowed to talk about technical events. Multiple models emerge because you start seeing different people know about different bits of business flow, so therefore you start seeing these multiple models. The bits of yellow tape are where he goes, oh, that sounds like there's two different separate things happening, so I'll stick a bit of yellow tape. And then that causes a fight because people say things are on different sides of the tape, and he slowly separates out this business architecture. It's got aggregates. He's got specific techniques for designing aggregates because, again, aggregates should be domain-focused, not technically focused. And he's like, we've got all of these pieces of information. Why don't we start designing software? Aggregates are what he designs first. Because you've got the multiple models and multiple bounded contexts, you can see team splits. You can even see, it's a really good way of seeing like the Conway's Law, how it's turned into your organization, because you can see different departments. Because different people from different departments will stand in front of different parts of the rolled up piece of paper and do them in different ways. And ubiquitous language. You will see, because you're not allowed to use technical terms, what the business people call things. You need to police it, because it's interesting how much the technical language bleeds into the world and the minds of business users. But you can use that and say, right, we're not updating a database. What are you doing? Oh, we're storing like some customer record. Okay, cool, that's a bit more. All that kind of stuff. That's all event storming. And it's all very much back to DDD. Does anybody know what this one is? Nope, not event-driven architecture. Subdomains, yeah. So what have they? It's team topologies. So team topologies. I'll press the button. Team topologies is a way of. It's come out of the DevOps movement. There are but fundamentally, it's a way of splitting up your organization and organizing your teams so they can be as maximally independent and flow-aligned as possible. Because we all do flow-aligned teams, because we're all doing product development these days. And what we want is teams that aren't, different people are working on, one big group, as you can see at the top, are working on various different parts of the software. What we want is different parts of the software being owned by specific teams so that they can know it in depth, have lower cognitive load, and can build better software independently. Team topologies. One of the ways of splitting things up is to use domain-driven design. Other ways are possible, so they talk about other ways in their book, Matt Skelton and Manuel Pais. But one of the ways of doing it is DDD. So they've got the business focus, because that's how they split things up. They've got bounded context, because that's how you know that your bit of model belongs to you. It's one system that doesn't belong to anyone else. And the whole point is you're doing team splits. And then the last one. Does anybody know what this is? This is quite new. So this is data mesh. Data mesh is catching on. Data mesh is why Eric reckons there's a current resurgence in DDD, because data mesh data mesh, I'll explain what data mesh is. Data mesh is an evolution of data lakes, because it goes, data lakes were bad because we took all of this awesome data and we just flowed it into a lake minus all of the context. So I've now just got a big soup of data which I can't do anything with. What we should do is build a bunch of closely connected data islands and then wire them together. So these are kind of like the islands of data from the runtime systems. But then if I want to do clever things based on that, like use it for doing data analytics or data machine learning or whatever, I can plumb into those systems' data and suck out their data and have copies of it, and then I can work on it, manipulate it. And maybe I can take data from 7 different places, maybe I take it from one place, whatever. All of these clever things, you can do them. And to do that, you need not all of DDD. In fact, you need not a great amount of DDD. But the fundamental things are you need these pieces of data and you need the context from which they came, and you need to continue to treat them separately. So all the discussion about business focus is still in the data mesh community. Bounded context, they use it all the time, but they use subdomains actually as well. And multiple models, because they don't have a big soup, which is a data lake. They've got a data mesh. So read about that if you get a chance. So, to summarize, domain-driven design. Hopefully I've given you an idea that if you had the sense that DDD is complicated and there's lots of moving parts, that's correct. DDD is complicated and there are lots of moving parts. But more importantly, there are a few really important pieces which if you get your head round, you can understand and then start going off and doing DDD today. If you wanted to read the blue book, you could read, I think it's the first chapter, which is ubiquitous language. You could read the next pattern in the next chapter, which is model-driven design. And then if you wanted, you could read a chapter called Supple Design, which is basically how to do guerrilla DDD. So you don't even need your team leads or whoever's permission. It's just about going, right, well, so the user said, I don't know. So for example, you might book a new transaction if you're in a banking app, but you've got a thing where it's a REST API, so you're posting the new transaction, right? So what it would do is it would say, right, you can just change the name of that interface to book. It's still a post at HTTP level, but as soon as it gets into your domain, it's not called post, it's called book, right? So you're booking a transaction. It's all about stuff like that. And it's loads of stuff which, if you read it, is very functional. So again, from 2003, Eric Evans was thinking in a very functional way. All of those things, you could just work on your little part of the code base and just make it more explicit, more domain-focused, and it would be of a benefit to people. I've said this a lot, and nobody's ever come and punched me, so I'm assuming that it hasn't made anyone's code base any worse. But that's it. The key thing is it's domain-focused and it's domain-aligned. That's the thing. You can build software in other ways, right? If DDD didn't exist, we would still have software, and we probably wouldn't have bad software. But when software gets complicated, DDD gives you the tools to see through that and figure out the fact that you're trying to solve 7 problems in one place. DDD gives you the permission to split those into 7 different things and solve each one separately. And that's why architects like it. That's why I like it as an architect. Because trying to solve multiple problems in one place is never going to work. So understanding the problem and understanding there's 3 problems or 4 problems or 2 problems and splitting them up and tackling them one at a time, that's the fundamental of software development. At the class level, at the function level, at the package level, at the microservice level, all of those pieces, it's just splitting up a big problem into smaller problems, and DDD gives us an awesome way to do that. And that's it. Thank you. Does anybody have any questions? There is a question. From Penelope. She might be online. Blue Book or Red Book for someone who wants to learn about DDD but doesn't have a lot of time and patience to read both? Asked Penelope. I'm biased. I would read the Blue Book. However, I have my last 2 clients, so some people here who worked with me on my last client. If English is not your first language, the Blue Book can be pretty tough going. So I would read the Blue Book. We did it as a reading group, so you can discuss things, talk about things. We started talking about the problems of, we're talking about ubiquitous language. What would ubiquitous language mean in this context, in this business sense? That was super useful. But I would recommend the Blue Book, because then if you get that, then you'll know when you go to the Red Book what the differences are. The Red Book also has this weird cartoon thing with these cowboys discussing things, which I think confuses everyone. And so you'll also hear the Red Book referred to as the cowboy book. You could read the entire Red Book and not read the cowboy chapters, and you would be none the worse off, I don't think. But it's not bad, but it's very prescriptive, the Red Book. And if you're a developer, if you want hands-on, if you want to do DDD tomorrow, Blue Book, because you've got to do tactical, and then you might do strategic, but if you're not taking the model and putting it into your code and your code shipping to production, you're not doing DDD. You might be getting some of the benefits, but it's not going to give you all of this stuff. So hopefully that answers Penelope's question. Does anyone have any other questions? Yes, go.
So let's say development is like team game, let's say, yes.
Yeah.
If you solve DDD to me, how am I supposed to serve that to my team?
So that's the best bit. So the ubiquitous language, the best bit about ubiquitous language is you are co-creating it with your team, across the team, so everyone's talking the same language. Like the best code bases I've ever seen, the most hospitable code bases, the ones where the cognitive load of reading a code base and then looking at a new feature request or a conversation I just had with a business stakeholder or something, a properly, cleanly DDD-driven code base looks like it was written by a collective group of people who understood this collectively arrived at domain. This ubiquitous language. So, and things that I've talked about in other talks, but I didn't put in here, ubiquitous, like you're not just listening to the business users and then writing what they say into code. They will be inconsistent. They won't really understand what they're talking about. They will be confused about things. They will be not specific and detailed enough to turn it into code, right? So we're like, that's awesome, but can you please be a bit more specific? You are co-creating a language with your domain experts, with your business users, and across the team. So therefore you say, you realize we're using 3 words for this thing. Why don't we just pick 1 word and call it that? And then we'll have the microservice with the same name. And then the names of the available functions of the microservice will be these things. And then when we talk to the user, we'll talk to the user using the same words. The empowerment that can give a team is super big. Like it just, the cognitive load of just everyone agreeing with each other all the time just disappears. And when you've got it, it doesn't even feel hard because you're not even, it's already there. It's already in the domain. You're just kind of discovering it. And maybe you're tweaking it. Where I am at the moment is a startup. So they're doing things which don't exist. They are creating the domain, but that's even harder if they don't agree because the business people and the product owners are coming up with ideas that the developers don't even know has happened because they haven't talked to them. But they can talk to it and do the stuff. So that's it. It's the power of ubiquitous language and taking that and putting it in software. That's it. Then you can do all the clever stuff. But if you do that, then you're... Any other questions? So the question is, that's a good question. If you start with a big monolith, how can you do DDD? You totally can. You can start with, so I naturally jump quite quickly to splitting things down, but just because I've got better at noticing where things split up, you totally can split it together. And the first things you do, and this is what we do in the training course that I wrote for O'Reilly, we start with what we think is one problem. So it's always best to assume you've got one problem. At some point you will realize there's more than one problem. So you split it up. And the way you get there is you use packages, you use modules, all of those things, but within the same repository. And then, just like Kent Beck would say, if it's not duplication until you're completely convinced that these two things, it's not separation. So Kent Beck would say it's not the same thing until they're exactly the same. DDD is like it's not separation until you're sure that they're completely distinct. Then you can keep them distinct in your code base. And then if you're sure, then you can slice that off and put it in a separate repo. Because if you split it up at the start and put 7 pieces in separate repos and they shouldn't be separate, that's painful. Yeah, go. Yeah.
So we are kind of forced to give the monolithic first step.
Yeah.
Then we come up with this problem.
Yeah. It is. So actually, there's a talk that Gayatri, who's in the front row, and I've done. It's one of the most photographed slides that we've got in our talk that we do, and it's MVP is the near enemy of domain-driven design. Because if your MVP is too M, if it's too minimal, you won't explore enough of the domain to figure stuff out. But you can hedge your bets by keeping it all in one place until you've built more, and then you can discover stuff. Because like I said, DDD is iterative and evolutionary, so it helps you evolve and find stuff. If you're doing big DDD up front, then you're going to fail. But you do need to do just enough to kind of figure out when you want to split stuff off. So any other questions? Yeah, go for it.
About the teams topology, then we saw there should be base teams around the domains.
Yeah.
How does it correlate with the Conway's law?
So yeah, the question is how does team topologies go around Conway's law? So it's basically you're doing what's called the reverse Conway maneuver. So you're structuring your organization around about how you're structuring your software. Because there's a really good quote from Michael Nygaard where he says, your HR department, whether you like it or not, are doing the first cut of your architecture. Because if they're splitting your teams up and giving them responsibilities, Conway's law will tell you that that's how your software will be split up. So if you get ahead of that and say, how do we want to split it up? So how we're doing it at my client at the moment, or not, the client started before I arrived, or we arrived, other people here are doing it too. They aligned to their product and they found the splits in their product, and then they staffed the teams aligned to the product splits, and then we're aligning the software to that. So that's how we consciously design the human structure, because as Eric proved and Mel Conway proved, all of these things are super tightly coupled and tightly related.
So if I want to have like feature teams in my organization, then I step away from them.
Yeah, you want to align them to the domain, the subdomains, the things that are like the business, things that go together as a chunk of business stuff. And then they will own a bounded context, and if the bounded context aligns to it too, then you're winning. At the moment, we're engaged in lots of stuff because we split the teams up, but we haven't split the architecture up. So the teams are blocking each other all over the place because bits of the architecture are in the wrong place. We're driving our refactoring based on how we've refactored the teams. Because the teams are split right. The architecture wasn't ever written to be split like this. So now we're refactoring the architecture to be aligned, because that's aligned to the domain. Sorry, go for it.
Yeah, and next question.
Yeah, no, so yeah, that's fine.
So you've talked a bit about
you had any failure stories, so to say? So
Yeah.
what mistakes can we avoid when trying to do that? Well, like scenarios where somebody was not convinced and the company moved out of implementing?
Because I'm over time, there's a whole talk. So if you Google it, this is what Gayatri and we did a talk called The Near Enemies of Domain-Driven Design. So we talked about how we landed somewhere and there was some stuff that wasn't working, and then I tried to fix it, and I fixed bits of it, and I made some mistakes, and then Gayatri came along afterwards and fixed the mistakes I made. So there's a whole talk about it. Lots of it comes down to not having a big picture view of stuff and not trusting the domain and going with the domain. That's the big stuff. And bringing in too much DDD when you don't need it. If you start at these small core elements and then bring in extra pieces as you need them. So in that talk, we talk about how the entire architecture was built with CQRS, even some CRUD microservices. So if you've built CQRS, you don't need that for CRUD microservices, right? So it was just over the top. Other stuff was super good. It was like super exactly what you needed. And that's where DDD can get a bad name, because sometimes people are like, there's too much DDD. I got called the DDD Messiah on that project because I kept talking about it so much, and then I realized maybe I shouldn't talk about it all the time. That's it. Thanks for all your questions, and thanks for coming.